All right, welcome back, everyone. So we have our final panelist for today. He's been a seasoned developer for longer than I have been alive on this planet. With 35 years of experience, let's welcome the founder of Nelkinda Software Craft, carrying tremendous experience in software development and software craft. Here's Christian talking about why we need to stop microservices before it's too late. Welcome, Christian.
Okay, good evening, good afternoon, good day, good morning, everyone. Can you see my screen on all cams? Does it work?
Yes.
Okay, great. So welcome to my session today. I have 1 hour and I couldn't resist the temptation to do what I usually do as soon as I have 45 minutes or more. I first talk a little bit about something else. And I'm going to talk about a bigger picture. So let's look at the future. What do you see in this picture? And by the way, I don't mind if you're interested in something, if you interrupt me during the talk. I like my sessions to be interactive and we're online. That makes it very easy compared to a physical conference. So if you want to talk something or you think you have something to contribute or so, just unmute yourself and speak over me, okay? Okay, so what do we see here in this picture? We see a Ford Model T. Yeah, that's obviously not the future, but it is by someone who saw the future. This is a very special vehicle. Does anyone know what's so special about this vehicle? This is the first assembly line manufactured vehicle. This is from the, we can almost call it already the end of the Industrial Revolution. This is where the Industrial Revolution found its peak. The fact that today we can enjoy the technology that we're using is partially a consequence of the Industrial Revolution and the assembly line, where it finally found its peak. What Henry Ford achieved with the Ford Model T is that everyone can now afford a car. Before that, the car was really a toy for very, very rich people. And this, with the assembly line, made it accessible to everyone. What do we see in this picture? Does anyone know who that person in the picture is? What's your guess? I mean, hopefully it's obvious where this picture was taken. But who is in the picture? Who is in the picture? Whom do you see?
Is that you, sir?
The guess is almost correct. Neil Armstrong was the one who took the picture. What you see in the picture is therefore Buzz Aldrin. Yeah, the two people that first set foot on the moon. When did this happen? That happened in 1969. Yeah. People have started talking about my age. That's actually older than me. Yeah, I was born in 1975. And what do we see in that picture? That is a space station. That's an orbital station from the movie 2001: A Space Odyssey. That movie was shot in the same year as the moon landing. That movie is from 1969. And the title, 2001: A Space Odyssey, suggests that the movie depicts how people in 1969 envisioned the world would look like in 2001. We would have an orbital station that is not small, it's big. If you look at the white slit in the midst of the station, that's actually the portal in which spaceships would land. And the space station rotates. This is another scene from that movie where you see people sitting in the station. Yeah, and you see the station is so huge, it feels like a real human habitat. And when you look at the end of the scenery, you can see it's slanted up. That's because the floor that the people perceive is actually the outer wall. So the the feet of the people go to the outer ring of the space station. The space station rotates to replace the missing force of gravity with the centripetal force. Yeah? So I grew up with these movies. I was born in 1975. I was promised spaceships, space stations, and lasers. And now we have 2021, and I have to ask myself, where are they? I was promised something and it isn't there. So what happened? Somehow our evolution in technology went in a different direction. Yeah, the space shuttle program was not that successful. In the beginning it was, but we didn't even go to the moon again after the Apollo program. Yeah, the space shuttle just went to low Earth orbit most of the time. A few missions a little bit further than low Earth orbit, but that was it. Now let's look at something different. What do you see in this picture? What's that car? That's the Tesla Roadster. Yeah. What's so special about the Tesla Roadster? Most people think it's the first electric car. No, it actually isn't. Yeah. There were a number of electric cars before the Tesla Roadster. For example, the Venturi Fetish, a few years before the Tesla Roadster. But Venturi is a small sports car company from Europe. They just build like 5 to 10 cars a year or something like that. And even 100 years ago, Porsche already had electric cars. But somehow electric cars didn't take off. What's special about the Tesla Roadster is that it's battery driven. But most people think that it's battery driven because Elon Musk wants to save the planet with battery driven cars. But that's only one of the reasons. The other reason is something else. The other reason is that Elon Musk wants to go to Mars. And on Mars, a combustion engine doesn't work. You don't have atmosphere, at least not enough, and you don't have oxygen. Now let's look at the next car from Tesla, Tesla Model S. That car also has something special that is connected with Elon Musk's mission to bring us to Mars. That is its biodefense mode. What is its biodefense mode? This car's cabin is always overpressurized. The pressure inside this car is always a little bit higher than outside. What's the consequence of having higher pressure inside the car than outside? You will not have air coming in. Yeah? On Earth, that's what happens. So this car has already helped people in the Californian wildfires to get safe from the smoke in the air. Quite useful. But why? Because if you bring a car to Mars, you need the cabin to be overpressurized at all times because your atmosphere around you has almost no pressure compared to Earth. This is again a piece of Mars technology that Elon Musk is putting in cars. Next, the Tesla Model X. Why does this car have these wing doors? Yeah, of course, they look fancy, yeah? But why the wing doors? Imagine you're a technician at Mars and you have to go from one place to another and then do maintenance of something outside maintenance. You're certainly not going to walk around with t-shirt and jeans on Mars. Instead, you're going to wear a heavy spacesuit. And while you probably haven't tried it yourself, you can imagine that getting out and in of a car in a heavy spacesuit with regular doors is going to be quite difficult. But if you have these wing doors, it's going to be easy. Yeah? And obviously, this car is not going to go on Mars, but at least develop the technology for having these wing doors. And actually, the Tesla Model X is already being used for space purpose on Earth. This is the car with which the astronauts commute from their preparation room to the actual capsule. For good reason, because you can easily get in and out. Yeah, so that's the Tesla Model X. And then what's that? That's also a brilliant thing using computer technology to finally land rockets. If you look at the economics of rockets, like 15% approximately of the cost of fuel 85% approximately of the cost are the rocket itself. Throwing that away is economically nonsense. Elon Musk understands that if we want to go to Mars or also to Moon or somewhere else, we have to change the economics of space flight. And he's doing that, yeah, with reusable rockets. Then what do we see here? Anyone, any idea? There's a picture taken moments before release of a bulk of Starlink satellites. That's again dual-use technology. Elon Musk is not only doing Starlink in order to have a business model with which he can use his own company to create satellite internet for the entire planet, where you can get satellite internet in all regions. But if you think you want to go to Mars, there's two ways how you can do it. One is you have a small station on Mars with 5 people. That's not really colonization. Colonization means to go there in hundreds and thousands of people. Yeah, but if you want to be on Mars, you are exposed to a risky environment, and you need backup, you need redundancy. You can't just have all people in one spot. They have to be spread across the planet in order to make sure that in case something bad happens in one place, like a huge asteroid crashing into Mars that isn't protected from the atmosphere, or volcanoes that we didn't know, other stuff we didn't know about Mars. Who knows what can happen there? We have no experience. Yeah, you need redundancy, you need backups, but then how do you make that communicate with each other? In general, just how do you get internet on Mars? You can't rely on the centuries of built telephone lines that we have here on planet Earth. You need to have cheaper technology. And in fact, now, if you look at the situation for Mars, satellites are going to be cheaper. Yeah, again, a dual-use thought. But if you want to colonize another place, then there is a problem. And we had this problem in human history with bad experiences. Whenever colonization happened, humans suffered. Yeah? Why do humans suffer when we colonize? When we colonize, we want to bring the level of civilization and urbanization that we have at our home to somewhere else. But the level of urbanization that we have achieved in one place has been built over decades, centuries, and millennia, and you can't just build that somewhere else overnight. It needs a lot of labor in order to create that. And I was giving similar talks in the past, and always mentioned that, in my opinion, there's one puzzle piece missing for Elon Musk, and that is robots. How do you get cheap labor? Yeah? And that now is solved. Yeah? If you followed the news, that is the Tesla bot. Yeah? Announced yesterday, Tesla is entering the business of making robots. Now, if you think of this from a product strategy perspective, how does that fit together? Tesla is a car company. Actually, it isn't. Yeah? Tesla is not a car company. Tesla is the company to provide everything you need for colonization of a planet that is moving on the ground. That is what Tesla is about. Cars, solar cells, batteries. And if you look at the robot, why is Elon Musk not just making electric cars, but why is he striving for autonomous cars? Now, of course, dual use, they sell better, but also the same technology is used for robots. If you want to build a robot, the robot has to understand its environment. And in order to understand your environment, you need a lot of sensor and processing technology. And whatever has been gathered as information, as data and experience from the autonomous features that the Tesla cars already have, you now get it back in the Tesla bot. That is something which I find very inspiring for us as technologists to experience. I think we are having very great times ahead. But obviously, me talking about Elon Musk is not what you've been paying for tonight, right? So let's move to our actual topic. Stop microservices, unless you already know what you're doing. So that's going to be the main topic of my talk. And those who have already listened to me in previous sessions will know that I actually never talk what I announce I talk about. Instead, I'm going to talk about extreme programming. But of course, there's still going to be a link. So if you came here for microservices, I promise you will not be disappointed. But for me, since I read Ken Beck's book about extreme programming, for me, software development at the core, no matter what we do, is always about extreme programming. So let's see, what are microservices? Service-oriented architecture. That means we try to get the core business functionality to the user without giving the user the binary. Why do we not want to give the user the binary? There are a number of reasons for that. One is we can update whenever we like without that the user has to undergo an update. Another reason is cloud is simply comfortable for the user. You just go to an internet cafe, open Gmail, you have your email. Open another tab, Google Drive, you have your documents. It's really just very useful and comfortable to have a service-oriented architecture. Then loosely coupled services. That means you have different elements in your service-oriented architecture that are running independently. We're gonna come to that in more detail. Fine-grained and lightweight protocols. We've had a few goes at service-oriented architecture before microservices, and not all of that was successful. If you know a little bit of Unix history, you will know there was Sun RPC. Sun RPC has historically been very important for the evolution of Unix and also the early days of cloud computing. It provided the foundations for NFS, the network file system, and NIS, the network information service. Nowadays, they're largely replaced with other things, and we actually stopped using NFS mostly, and we use different technologies now to remote access files, and NIS has mostly been replaced with LDAP, but it was an important step in our evolution. And then we tried other things, and oh my God, were they a disaster. Like Corba with IIOP and Java RMI. And if you ever try to get Java RMI running, oh my God, you know what I'm talking about with the RMI registry and so on. And then we tried SOAP, the simple object access protocol. And if you've ever tried SOAP, you know that the person who designed the name didn't know what they're talking about because it's everything but simple. But finally, we figured that we can just use HTTP as a protocol for connecting our services, and that works pretty well. And then we also said, okay, what's a good way to exchange data? XML, most people still think it's a little bit heavyweight. XML doesn't have to be heavyweight, it can be lightweight, but then you have to know exactly when to use an attribute and when to use an element. And if you look at the XML formats out there, a lot of people that design formats there don't really know. So we found JSON as a format works pretty well, and that's what we call a lightweight protocol. It's not as lightweight as it could be from the perspective of what is the payload that has to go to through the network, which, by the way, is something you have to take into account when you look at microservices. But it's lightweight compared to a lot of other approaches that we had. And especially it's lightweight in the term of what efforts do you have to undergo if you just want to update something. Let's say you want to support a new field in JSON, you just add that field. You don't even have to talk with anyone. You just add that field and everything's still working. You have some forward compatibility by just how it works. And you don't have to exchange any contracts like interface files or IDL files or something like that. No need to exchange those things. You can exchange stuff if you want to, like your Swagger files, for example, but you don't have to. Yeah, just a verbal description and maybe a little bit of self-discovery will just do the magic just as well. And another aspect of lightweight is obviously how easy it is for us developers to deal with it. Yeah? Since the protocols are text-based, debugging stuff is pretty simple. Yeah, but obviously the lightweight protocol is not specific to microservices. You get that with a monolith as well. So what are the typical tech stacks that we use? C#, .NET, Java Spring, Kotlin Spring. There's a few other frameworks out there as well, like Ktor and so on, Golang, Python/Flask, many others. That's the typical tech stacks. And why do we do it? Why are we going for microservices? There's ancient Unix wisdom that says, do one thing and do it well. And microservices support horizontal scaling better. So what is horizontal scaling? Horizontal scaling means that we can scale by adding more nodes to the system, whereas vertical scaling means making the individual nodes more powerful. That's the difference between vertical and horizontal scaling. So how does the opposite of a microservices architecture look like? It looks like this. Yeah? You have your API gateway, maybe not even that, maybe everything talks directly with your monolith, and the clients like web, iOS, Android, they are talking to your API gateway or to your monolith. Everything happens inside your monolith, and then you talk to the database. Now, can anyone tell me why we don't like monoliths? Now, you can just unmute yourself and talk, or you can just put it in the chat if you like. Why do people hate monoliths? Why have they come out of fashion? What do people think?
It is harder to scale.
Can you please?
It's harder to scale.
Harder to scale?
Yep.
Could be, yes. That can be an aspect. Yeah. It depends. Yeah. It depends on what's going on within the service. But yes, in certain situations, it can be harder to scale. Yeah, the next one. Oh, very good. Very good stuff in the chat. Yeah, I'll repeat that. So Raj said, when something fails, it makes the whole app goes down. Yeah? If your monolith is down, your app is down. Everything is down. Nothing is working. Yeah? You don't have an 80% or 90% working app if your monolith is down. If your monolith is down, the app is down. Yep. Then everything comes inside a basket, which makes it messy. That's where I have to say, just because you're running in the same process doesn't mean that your code has to be a mess. It's our job as software engineers to make sure we don't make a mess. We're going to talk about that in a little bit more detail in a moment. Building takes a lot of time for monoliths. Can be. But that's also connected to the mess. Why do you have to rebuild the entire monolith? Your monolith could consist of modules that you build independently, so you only have to rebuild the module that you changed. And then you just assemble the monolith with all the pre-compiled modules. That works just as well. And I see an interesting discussion in the chat going on. Yeah, Raj responded to that. It's the opposite. Microservices takes more time. Yeah, because deployment actually takes a lot of time with microservices, but also testing. Yeah. But let's look at the structure, at the mess that was mentioned. Yeah. So here now I'm presenting you the topic horizontal versus vertical architecture. You see in both sides, a cut of the same application, but it's structured differently. On the side horizontal, you see the code, and I've chosen Java for the example because I guess many of us will know Java. It's still kind of a lingua franca for high-level programming languages, although it's not a very nice language. If you want, if you have a local meetup group, invite me so I can bash Java and promote Kotlin and a few other languages if you're interested. And on one side, you see the structure that I see in most projects that I see when I consult. It is the horizontal structure. And the horizontal structure was also found in the early tutorials from Pivotal about Spring. And then we have the other structure, the vertical structure, where you see this is different. Yeah? You see that the view on the code is not a technical view. Yeah? Instead of talking of controllers and models and services and repositories, we're now talking of customer and order. Yeah? That's what we call a vertical code structure. And only one of them is maintainable. Only one of them follows the principles of object-oriented class design. Which one is it? Put your guesses in the chat. Which one is better, horizontal or vertical architecture for your microservices or your monoliths? Now we have one vote for vertical. Seems to be a pretty mixed picture. I've counted 5 for vertical and 4 for horizontal so far. Okay, I'll resolve it now for you. The vertical structure is the structure that you should have, not the horizontal structure. The horizontal structure gives me as a developer information that I already have. You only need to mention Spring, and I know that I'm going to find controllers and models and repositories and services. And I already know that my models might also be segregated sometimes into entity models and view models, and I might have a few other things as well. I already know that just by you mentioning Spring. And if you mention something else like .NET, then I know, okay, I'm going to have the same thing, but some of the things will have different names. But it's still going to be the same thing, more or less. I already know that. But now, when I have to make a change, how does that look like in the horizontal structure? Most changes that we make for business. If we have to make changes for technical reasons, that should actually, if we do our job well, that should be rare. So when we look at change that we make, maybe, for example, we want to add middle name to customer. Yeah, there was this guy, Amit Patil from Mumbai, who told us that he has problems ordering because he lives in a skyscraper in Mumbai with 50 floors, and in the same building, there's 4 more Amit Patil. So let's add the middle name to reduce confusion. So we add the middle name. What do we have to change? We have to change the customer controller, maybe. We have to change the customer, certainly. We have to change the customer repository, maybe. And we have to change the customer service, maybe. And if you look at how many places you have to visit in the horizontal structure, you have to go all over the place. Whereas if you look at the vertical structure, you just go to customer and make the change in one place. And the purpose of a good architecture is to support future change. There's a lot of other purposes as well, but one of them is to support future change. When you look at this from a different perspective, yeah, use the vocabulary coupling and cohesion. Yeah? What does cohesion mean in software architecture? Cohesion means these are things that change together. The controllers don't change together, unless you replace HTTP with something else, but why would you do that? The repositories usually don't change together. Maybe occasionally they do. Maybe you're migrating from MongoDB to Postgres. Then the repositories all change. But these things are rare events. The primary events that we have to support are the regular daily business improvements, the new features. And that's what our architecture should support. And then when you look at this from the perspective of cohesion, cohesive things are things that change together. The vertical architecture is much better suited to support our daily business. And you have a problem when you follow the horizontal architecture, because then you exactly have the problem why we don't like microservices. There's a number of reasons why we don't like microservices, but that microservices code is a mess quite often is one of these reasons. So let's not have a mess. Let's go for a vertical structure. And now if you think of the following, so how do you design a microservices architecture? In the beginning, you probably don't know. And if you don't know, you actually shouldn't do it. If you don't yet know how your microservices architecture is supposed to look like, then better keep your hands away from microservices for the time being. Start with a monolith. Learn what your business is. Learn what your business problems are. And once you know that, then you will understand where your bottlenecks are and what you need to scale, and then you can break out. But then if you look at this from the perspective, you want to break out your microservices, which architecture supports the path from monolith to microservice better, the horizontal structure or the vertical structure? I think it's a pretty clear thing, isn't it? Because we obviously don't make a microservice for the controller and a microservice for the repository, although maybe a little bit we do. We'll see that in the next slide. So the vertical structure supports breaking out into microservices far better than the horizontal structure. The horizontal structure became popular because the first tutorials from Pivotal have shown exactly that structure. But why have the people from Pivotal chosen the horizontal structure in their tutorials? Well, I haven't talked with them, but I can guess by just putting myself in the shoes of someone explaining a framework. That was the message they wanted to get across, just to explain how Spring works. So you have controllers, you have models, you have repositories, you have services, and make sure it jumps in the reader's eyes. Okay, let's make packages so that everyone understands how the technical architecture works. They've changed their tutorials because they didn't expect everyone copying that aspect of the structure. They thought everyone has read Robert C. Martin's papers about the solid and package principles. But actually, a lot of people haven't. A lot of people also think that the solid principles are 5. No, they're 11. They just skip the other 6 because they've never heard of them. They are the package principles. And the package principles are, again, the principles that tell you about the vertical structure. They tell you that, the package principles. So we have to go for the vertical structure. That's how a microservices architecture can look like. So your web, iOS, Android talk to an API gateway. And then over time, things grow messy. And then if it becomes big, you're going to have separate databases, because someone tells you that every microservice needs its own database, it has to be self-contained. I think that's partially true and partially rubbish. As so often, the correct answer is it depends. You have to figure out what's better for you. And sometimes it can be better for microservices to share the database. It just depends on what your situation is. Okay, so now if you have shared data, but you follow the rule that you don't share databases, the next thing that happens is you want entity services in your microservices ecosystem. So that all you can do is share the data that you need in multiple session services. The session services is where the real stuff is going on. And then you find out that you have too many API calls coming in from iOS and Android from the mobile phones. It's just making the user experience bad, because in order to navigate to the next screen, you have 7 API calls. So you introduce an experience API and you introduce a cache. And now the next thing you find out is that everything is still slow, despite your experience API. Why? Because making a call from one service to another takes a hell lot of time. Yeah? Even if you think it just takes 5 milliseconds to make a call from one service to another, yeah? I mean, if you compare this with a local method call, that's like 5 nanoseconds. And between 5 milliseconds and 5 nanoseconds, there's 6 orders of magnitude. Yeah? So you have your experience API aggregating all the data. The experience API calls the session service. The session service calls an entity service. Then the experience API is making the next session service call, and the session service again calls an entity service, and maybe the other entity service as well. These 5 seconds, they accumulate. It's bigger over the call tree. So you might be spending like 50 to 100 milliseconds in that single API call just to get all the data from all the other services. So what do? You throw in asynchronous calls. Now you have fun with asynchronous programming, solving a problem that with a monolith you wouldn't have in the first place. In a monolith, you just make a local method call, 5 nanoseconds. The microservice, 5 milliseconds. Okay, let's speed it up. So you make async calls. Next thing you do for speeding up is you introduce a cache. And while you're introducing the cache, what you find out is that your users are telling that there are bugs in your system. Okay, now you figure out where the bugs are coming from. The bugs are coming from that your asynchronous calls will, for updates, lead to inconsistency. Yeah, you have replaced consistency with eventual consistency. So now you're updating all your business logic in order to deal with eventual consistency. And one of the things that you introduce in order to deal with eventual consistency and also with other problems is you introduce a message queue. No one can tell me that this is simpler than a monolith. A monolith can also be a hell to work with. Yeah? If you cause chaos in a monolith, it's going to be hell to work with. But microservices are not the solution for that problem. The solution for that problem is writing clean code, creating a clean architecture. The solution for that is to understand the clean code principles, the package principles, the class principles, the 4 rules of simple design, whatever you want to pull out of the shelf of good coding practices. That is what solves the problem. If you're a team that made a mess with monoliths and you do not change your coding practices, I promise you, you will make a mess with microservices and it will not feel good. So be careful what you're putting yourself up with. Yeah? With microservices, you get a lot of problems, and then you have to pull tools in order to deal with the problems, to solve problems that you wouldn't need to have in the first place. Let's park microservices for a moment and get a little bit of process perspective. Yeah? This is where it starts connecting with extreme programming. So this is lean, the 8 forms of waste, which you can easily remember if you read the letters. They form the name Tim Woods. So Tim Woods is the waste guy. The first one is transportation, unnecessary moving of materials. Yeah, like moving something from one place to another. Then you have inventory, excess products and materials that aren't processed. Yeah, like let's say, and inventory is sometimes misunderstood. We have a very interesting example in our industry how inventory can be misunderstood. Even on the slide, it's not entirely correct. Inventory is not only a waste in case of you have excess products and materials, it's also a waste if you have too few. Some car manufacturers painfully experience that, just as I do. I actually wanted to buy a new computer this year. That's not gonna happen. With those GPU prices, no thanks. So gonna wait. And then we have motion, unnecessary movements by people. Motion, I'll show you what motion means. Yeah, motion, for example, means you want to introduce the middle name to customer, and when you have the horizontal structure, you have to move from package to package to package to make that change. Just already the distance you have to go through in your project to make one change is motion. Then with waiting, waiting for the next process step to occur. Over processing, creating higher quality or having more work steps than required. Overproduction, creating more products than required. Defects, failure to meet the customer expectations. And skills, underutilization of people's talents, skills, and knowledge. That's the 8 forms of waste. And now think what this means in the context of microservices. You get a lot of waste into your system by just having microservices. Conway's law. Some of you might heard of it already. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. How do you manage something like that? How do you manage something like that? You need probably multiple teams. By the way, multiple teams can be a good reason also to move into that direction, but you don't need microservices to have multiple teams. You can manage a monolith with multiple teams by having a good vertical structure. Conway's law. Most organizations are not flexible enough for Conway's law. And when you don't understand Conway's law, it will still apply. But the structure by which we deliver business functionality should be driven by the best technical representation to deliver that business functionality, means the architecture. And in most organizations, it's not the architects who make decisions about who is in which team and how the teams are formed. In most organizations, it's management and HR working together. So what you actually get in that situation is that you have an organization structure that is created not by architects, but by HR and management. And this organization structure has to deliver microservices. So they will create a microservices architecture that reflects the organization structure instead of the architectural needs. That's something that's also more difficult to deal with in a microservices architecture than in a monolith. Because in a microservices architecture, the next thing someone says, oh, process police, no one should have access to my service except my team. You don't change my code. And then everything gets slow. Now let's talk about slow in process. Let's skip this for a moment. Okay, so we have a group of people that want some features. And we have to deliver that. So how do we do that? Users, operations, management, marketing, sales, whatever, they say, we want something. So they have requirements and needs and ideas, and they want that to be turned into valuable features. And we have the other side, us, the techies, the developers, the engineers, whatever our role may be, and we have to deliver that. So to deliver that, there is a step called ideation. So understand the emerging requirements and say, what is really needed, understanding the difference between want and need, through conversation, finding out what the actual need is, prioritization, and so on. And the result of that ideally should be acceptance criteria. Yeah? I mean, some people say, why shouldn't that be user stories? For me, the acceptance criteria are more important. The user stories are a promise for conversation, but the acceptance criteria are something which I can use to verify whether I really have met the criteria of the idea. And then we have development, test and production code. And I consciously write test code first. For me, test comes before production code and not after. Test-driven development, behavior-driven development. The result is a verified executable. And then we have what people call the pipeline. For me, the pipeline, by the way, is the entire thing, not the step here right now. To build, verify, deploy, and that should be automated. And here's the question. So how fast can you spin that wheel as a team? That is critical for success. And it doesn't matter whether you're a small startup or you're a big bank. How fast you can spin that wheel decides your success. So how long does it take for an idea to be materialized as value in the hands of users and change their life experience and their behavior for the better? How long does that take? Yeah? Ask yourself, look in your environment and so on. And I can tell you that in a lot of companies, this takes weeks and months. And if you take the planning into account, it can even occasionally take more than a year. And in highly agile companies, spinning that wheel takes hours to days at max. So how do you achieve that? One of the things is you want this to be a feature mill and not a rumor mill. What do I mean by that? If you think of the Ford Model T assembly line, that works for the industry. The industry is building physical things. So I'm the guy who puts a car door on the car. Okay, assembly line, car comes, I put the door, car goes. Next car comes, I take the door, put it on, car goes. That's a situation where the handover from one station to another is in a very, very well-defined interface. The next car that's going to come, it's going to be, again, the same model. Yeah? Let's say I'm in a Volkswagen factory. First car that comes is a Volkswagen Passat. Next car that comes, again, is a Volkswagen Passat. Again, going to mount the same door to the same type of car. Easy handover interface. That's why automation is so strong. But we, as developers, we are not manufacturers. We are not people who construct code. The construction is performed by our build tools. The compiler is constructing code. Make, Gradle, SBT, Go build, whatever you're using. That is what constructs the code. We are the designers. The source code is a design and not the bricks of a house or something like that. The interface for handovers is highly volatile. If I get requirements, I'd better directly talk with the user. Every person that you put in the game between the users and the developers is turning your feature mill into a rumor mill and is a recipe for decreasing user experience. And it's also a recipe for making this wheel spin slowly. We want this pipeline to spin fast. What do microservices do to this pipeline in most organizations? They slow this pipeline down. They make this wheel slow. Because what happens when you look at this? Is it one team that's going to handle everything end to end through the entire microservices landscape in most organizations actually know. You will have a web team, and you will have an iOS team, and you will have an Android team. You will have an infrastructure team, and maybe a separate database team. And then each of the services has a team. Now I want to add middle name for the customer and see that on all three user interfaces, how many teams are involved in order to get that job done. Yeah. It's going to take a long time. Yeah. The web folks are going to tell me the same thing as the iOS folks and the Android folks, that they won't start their work until the experience API shows that field, because they say, how can I test this? Yeah. And I can tell them mock it 10 times. Yeah. But then they're going to come back to me. Yeah, we can mock it, but at least we need the API description. Okay. So I go to the experience API and say, we need to have middle name in our customer. So give me the new API description and say, oh, we're busy. Yeah. Okay. A week later, I have that. Now they can work. Yeah. But to get it to the entire system, that's going to take weeks or months. Yeah. There's this temptation that you break out into microservices for Conway's law, so that you can have separate teams managing different services. But be very careful about how you do it. It can work well, and it can be a disaster. Yeah? It works well if you make sure that your teams still have cohesion around business functionality. Yeah? Like one team is responsible for customer, everything related to customer, and they may change whatever is there in the system for customer. That's going to work. Yeah? But then you need a few things in place in order for that to make work. You need to have, for example, collective code ownership in order to make that work. Yeah? So that everyone can change everybody's code. But if everyone can change everybody's code, yeah, how do you prevent mess? You prevent mess by saying, okay, we can own the code collectively, but we all have to follow the same common coding standard. Yeah? You don't want to argue over curly braces or stuff like that when your multiple teams changing the same code base. You don't want to do that. You want to have one guy, architect, says this is how it's done, and you just follow. Yeah, you may argue with the architect, yeah, but don't argue with your colleagues. If you have a different opinion, try to convince the architect, try to convince the organization, but don't make a mess in the code base. Then you need to make sure that we don't break each other's stuff. Yeah, I might be changing a service that I haven't written. How do I make sure that I don't break it? You must have tests with good coverage in order to make sure that that's not going to break. Yeah, you need to have unit tests, you need to have integration tests, you need to have acceptance tests. Yeah, and you can label them differently if you like. Yeah, developer tests, for example, instead of unit tests, fine. Yeah, or component test instead of integration test, I'm fine. Yeah, but build your test pyramid from the bottom up. Start with the unit tests, then the integration tests as the gap fillers for whatever the unit tests can't test, and then the acceptance tests for the gap fillers, whatever the integration tests can't test. Don't do it top down. You can think it top down. That's great stuff, thinking it top down, because you take the user perspective right from the start, but don't do it top down, because that will lead to slow tests. First, pick the fastest form of test available, the unit test. Otherwise, you're again going to throw sticks in the wheels of your feature mill. Yeah? Make sure you have tests so that we don't break each other's code. And how do you keep your level of quality high enough in your teams that share a code base? You need to allow for continuous refactoring. You need to have continuous design improvement through continuous refactoring to get that done. Yeah? And if you've read the Extreme Programming book, you know that now I'm talking about extreme programming. And another thing that you need is you will still need to have a system metaphor so that everyone understands how the entire system works, what the architecture is. And the architecture vision, and you need simplicity. Yeah, you need to have a simple architecture and a simple design. What are the 4 rules of simple design? Kent Beck. Passes the tests, communicates intent, no duplication, and fewest elements. Microservices is not necessarily fewest elements. Depending on what you're doing, it might still be the thing. Yeah? For Netflix, it certainly is. Ask yourself how similar what you are doing is to Netflix. Maybe it is, maybe it isn't. Another check can be, how many users do you expect? Yeah? Do you do something B2B for a few companies where you expect like a few dozens or a few hundred or maybe a few thousand of users? You probably don't need microservices. Yeah? The value of your business in that case is probably not scale. Yeah? Sometimes it may be. Yeah? And the chances are not. It's not scaling. Yeah? Let's say you do something for doctors in a country. Software as a service for doctors in a country. How many doctors are there? Yeah, a few thousand, maybe a million. That's still not that many. That's not Netflix. That stuff is made for scale for billions. So you see, all the extreme programming practices are important. Then how do you make sure that you can easily understand code and that you don't have a buzz factor, like one guy knowing one service, that guy leaving, and now it's chaos. No one wants to touch that service. Yeah, you need pair programming or ensemble programming. So that's that. We had those. We can skip those, and then this is my closing slide. Yeah. Antoine de Saint-Exupéry, famous French author, and also famous for being a hobby pilot, that despite better advice wanted to be a pilot during one of the world wars, and that killed him. He said, a designer knows they have achieved perfection not when there is nothing left to add, but when there is nothing left to take away. We have a tendency to additive thinking. Whenever we are given a problem, we always first think, what do we have to add in order to solve the problem? But additive thinking is misleading us into complicated solutions. The goal that we should achieve is simplicity. And simplicity isn't always microservices. It can often be just a well-designed monolith. That's it. Questions? Oh, and my speakers are off. Give me a second. Now they're on. Questions?
All right, I see no questions in the chat yet, but if you have anything, you can feel free to drop them in the chat. Okay, I see one. I love to get assurance by writing tests, but for startups where requirements change too often, we would need to tweak the codes, but all the tests as well, hence slow delivery. How can we handle these problems?
Learn more about testing. It's a very good question. Yeah, learn more about testing. If that is your problem, you're probably testing in the wrong way. And one of the things that I see often going wrong in testing is people hear unit testing, and then they think unit tests test units in isolation, and then they interpret that isolation means that they really have to isolate the unit under test, and then they throw a lot of mocks onto the units. But that is actually coupling your unit tests to the structure of your system. But tests are not about structure. Tests are about behavior. Make sure that your tests are decoupled from structure as much as you can. The only thing, ideally, that your tests should know about the unit under test is the unit under test's provided interface. Because an interface is the element of structure that makes behavior accessible. And ideally, your test knows of nothing behind the unit. The unit may have dependencies, yeah, but your test should know as little of that as possible. Now that said, in unit tests, stay away from inversion of control and dependency injection containers like Spring, because as soon as you use Spring, you no longer have a unit test. Why do you no longer have a unit test? Because a unit test is a test that runs fast. And with Spring, your tests don't run fast. Yeah. And the isolation of time is far more important than the isolation of unit. Why is the isolation of time more important? Imagine the following hypothetical scenario. You only have one test, and that test doesn't tell you anything except for one thing, whether your system works or it doesn't. But imagine this test takes only 1 second to run. That would actually be heaven. Yeah, you don't need any feedback other than the test is green or red. The test is green, you start. You make a change, you run the test is still green. Okay, let's go to the next change. Test is green, okay, let's make the next change. Test is red, what's wrong? My last change. Isolation of time trumps isolation of structure. Yeah, when we speak of micro-testing in developer tests or unit tests, we actually don't talk of structural isolation. We talk of isolation in time and isolation of behavior first. And the isolation of structure is just a means to achieve those other isolations. So that's one aspect about the testing part. Yeah? Of course, you still mock. Yeah, as soon as you have a good reason. And what are good reasons? Yeah, like fault injection, slow and external brittle dependencies, like a database or so. Okay, inject that. Yeah, but in a unit test, try to not use Spring or something like that to inject the stuff. That's just going to make stuff slow. Yeah? So if you are in the situation where you find out that you frequently have to change your tests, then ask yourself, are you actually testing the right thing? Yeah? Are you testing on the right level, for example? Okay, next question.
All right, I see another question that asks, my question is, isn't acceptance and E2E test hard for microservice? Also, when microservices are connected, isn't data integrity harder?
Yes, it is. Yeah. So, I mean, if you have a monolith, how do you test the monolith? Okay, you need the monolith on your machine. Maybe the monolith needs a database. Okay, you need the database on your machine. Okay, but off you go, you can already test your monolith. You want to test the microservice, that microservice make another call to another service. Okay, so now you have to ask yourself, what level of test do you want to write? Do you want to have a partial integration test, which basically then only tests the integratability of your microservice? Or do you want to have an end-to-end integration test? And then you spin up thousands of containers on your machine just to test that little service. Yes, testing in microservices is also a point that is more difficult. And thank you very much for that inspiring question. Should I ever give this talk again, I'm going to talk about that as well. Thank you.
Awesome question, Raj. We're at the top of the hour, so we're going to take one last question if anybody has it. If not, I'm going to Robus's question where he asked, do you think it's a good idea to create common libs and utils and share among different concerns in vertical architecture?
Yes, absolutely. Yeah. So vertical architecture does not mean that you abandon the dry principle. The 4 rules of simple design should be your paramount guiding principles, whatever software you write. And the first one is passes the test. The second one is communicates intent. If those are satisfied, the next one comes into picture, and that is no duplication. And if you find stuff that you do repeatedly in different slices of your vertical architecture, most of the times you will actually find this is technical stuff. Then of course go ahead and create your own libraries. And then if these libraries are cool and you're happy with these libraries, then maybe do what other people have done before you and for which you benefit, open source them for the rest of the world.
All right, I see one more question from Anon just pop up on chat. Suppose my app may go viral among people, but no idea if it will. What model would you suggest to build my app, monolith or microservice?
That's also an excellent question. So monoliths are also scalable, and also monoliths can be scaled not only horizontally, but also vertically. They can scale in both directions. You can just spin up multiple EC2 instances or compute engines or whatever your cloud platform is. I hope it isn't Azure, because that's crap. So you can spin up multiple of them. Yeah, so go ahead, do that.
All right, awesome. I guess that was our last question. It was a very interesting presentation, Christian. Where can people find you if they wanted to?
I am very approachable, which you will find if you try to contact me. I am on Twitter, I'm on LinkedIn, I'm on Facebook. I'm not that much on Facebook these days because like the last update of the Facebook app that I knew like 4 or 5 weeks ago started crashing on my phone. So I deleted it from my phone and I usually don't open it on my PC. But if you send me a message, I will get it. So I'm also on a lot of other social media platforms like Zing and Pinterest and so on. But usually I use Twitter and LinkedIn quite a lot and a little bit of Facebook. You can also send me an email. You can visit my company website. The good thing is my name is unique. As far as I'm aware, there's no other person on the planet with my name. What a luck for me and you. You can easily find me. Just Google.
Fantastic. Well, that was Christian Hujer here talking about Tesla bots and microservices and why you should not, why you should stop before it's too late. All right, that is a wrap on day 2 of Syntax. Thank you everybody for participating and staying in until the very end. We'll be back tomorrow to talk about Amazon Web Services, success of a project, and much more. Feel free to drop your feedback in the feedback form provided in the chat. And if you want, you can reach out to the panelists for today on their social media handles. Thank you, everybody. Have a good night or a good day, depending on where you are. See you guys tomorrow.